All right, so determinants and inverses. What does determinant mean? Anyone know?
Something about finding.
All right, so if we have a matrix that looks like this, matrix A is often seen like this. Determinant A. Does that make sense? Or sometimes you'll see it as a little like triangle. So essentially what a determinant is you multiply the first diagonal. Does that make sense? And you then minus the multiplication of the second diagonal. When we do a 3 by 3, so we want, sometimes you can write a determinant with 2 lines like that. Okay, so we're going to find the determinant of a 3 by 3.
Wait, so you can write determinant as magnitude.
For matrices, the magnitude symbol is determinant. So what you do is you pick a row, right? So I'm going to pick the first row. You pick this and then you copy that next to it. All right? You then do the same thing but for the next letter. So B, and now we're copying this.
What? So you're just like moving it.
And then you would do the big equation underneath A times that determinant of that little matrix, the minor matrix, minus B times the determinant of that second minor. Does that kind of make sense? We're getting a bit advanced.
So
We're not, and they put like a little T, right? So what do you think it's going to look like now? This one up here.
Yeah, DC.
No, good try. The lead diagonal stays the same.
Oh, AC, B, D.
Good job.
AC, B, D.
All right, singular matrix is when the determinant equals 0. So you do this thing up here. You find the determinant AD minus BC, and those numbers become 0. Does that make sense? And we use like a little -1 to show the inverse, right? So we divide by the determinant, or I should say we have a fraction, a 1 over the determinant, multiplied by D negative C negative, oh wait, got it wrong already. Negative B negative C A.
Oh, you just flipped this.
So I flipped the diagonal and I made the other diagonal negative. Now if I go A by its inverse, right, or multiplied by its inverse, so row by column, row by column, row by column, row by column, I will end up getting, I hope you remember what this is, the identity matrix.
Alright, I think I've got it.
1 times 1, 2 times 5 is -9.
Yes.
So if we were finding the inverse of f outside the matrix would be There we go, 1 over minus none.
Oh,
And the next line of communication is, if it's 0,
no.
It's a singular matrix.
therefore G is a singular matrix. 12 minus 12
7.
equals 0. Therefore G is a singular matrix. Two times -3 is -6,
So, we're getting there.
minus 6 times 7. So -6 minus 42.
-48. See that quick maths?
Quick maths. 2 plus 2 is 4.
Oh, I needed that.
So the inverse is the determinant under 1 by that funky, weird version of A. So what's up here?
I'm
still trying to figure out this bit.
-3,
Wait, aren't you meant to flip the other
-6, -7, 2.
one? What?
Hold up, so you can switch the D and the A.
Shouldn't it be minus 2?
D and A. So -3.
No, I thought it was.
You flip the first diagonal and you make the second diagonal negative.
Oh, it is.
Alright, so let's practice our calc skills. 7, 8. Yep, so you can cheat and do the inverse on your calculator.
And it's an identity matrix, which means it will work.
It did work. Our letter, what's... Okay, so now that's A, -1.
Oh,
Look at that. So communication, how would we finish this? Therefore,
that's his R, which equals the root of
we can also check that other one I didn't check.
Oh, look what it says.
There we go. It's the determinant of a 3 by 3. That's what the first element, remember what an element is? Times by the first minor. Minus the second element by the second minor. You just find the determinants of those. So 2, 8 minus 2 minus 3, 6. Okay? 2 times 6 is 12. D minus BC. And that's a in menu 7 create matrix 3 by 3. All right, 3.
3, 2.
All right, I'm going to let this equal B. And now how do I get the inverse? Done. Let's go.